Welcome back! In the previous videos, we got an overview of the framework and we talked about setup, configuration and security. This time, we will take care of the plugins, which allow to extend Restart's functionalities in a simple but effective way. As we already said, the basic package contains two plugins, as we can see here inside official documents. They are Restart MongoDB.jar and Restart Security.jar, and they allow the interaction with MongoDB and the security management. However, it is possible to build some personalized plugins thanks to the framework's basic architecture. Before we go in more technical details, we must introduce some basic concepts. We must understand which type of plugins we can make. First, let's talk about the services, which allow to extend the API through the development of web services. Then we have the interceptors, which allow to analyze and modify the requests from the client to the server and the responses from the server to the client in different stages of their life cycle. Finally, we have the initializers, which allow to execute some initialization operations in Restart starting phase. In short, we can develop some plugins in Java and execute the deploy. This can be done by simply copying the jar file we got after the compilation phase inside the plugin directory, where we already have the two basic plugins. Before we analyze some coding examples, let's see how the plugins are structured internally. Let's start from dependencies. The only dependence required for the development of a new plugin is simply Restart Commons. We can see it represented here with a block which must be inserted in the POM XML file. This is a typical project based on Maven. Of course, it is possible that additional dependencies are required for the logic of the plugins that we are developing. In this case, the jar files of the different libraries will always be inserted in the plugins directory. However, we must be careful and avoid duplicates. This means that we must avoid copying the libraries which are already found inside the core. For this purpose, it is advisable to execute the command mvn dependency :3 inside the restart/core directory, which contains the source code. After a few seconds, we will see that the tree structure will appear, with all its dependencies included inside the core. We can see them here in this list. They do not have to be duplicated inside the plugins directory. All the plugins must show the @register plugin annotation. This allows Restart to find the specific classes inside the jar files and to specify proper parameters which can vary according to the plugin type. As we can see in this example, we have a class called MyPlugin, which implements the JSON service interface. We will see in more detail the different interfaces available. Right now, we just want to look at the @register plugin annotation. Inside it, we can see a series of topics which are specified. Particularly, the table that we see here indicates the different parameters available. Some of them can be applied in every plugin type, and they are indicated with all. Others are specific of a particular type instead. For example, default URI and don't intercept apply to service. The intercept point applies to an interceptor, and the priority applies to the interceptor and the initializer. Some parameters are compulsory and they are indicated with yes. Some others are not, and they have default values. Let's see now the parameters which are common to all the plugins. We will see the others in more detail when we will take care of the different types. The three common parameters are name, description, and enabled by default. Obviously, the first one represents the name we are going to give to the plugin, while this one is simply the description. Those ones are compulsory, there is no default value. The third one instead, which is enabled by default, establishes if the plugin must be enabled by default when Restart starts. How does it work? Well, When we create the plugin and we copy it inside the plugins directory, it can be enabled or disabled. By default, we can see that the value is set on true. This means that if we do not specify anything, the plugin will be working by default. As we can see in the example, there are the different parameters. So, for example, we have the name foo service and the description just an example service. Since this is a service, there is also default URI/foo, and then enabled by default equals false. As I already said, we will see the others later on. Another interesting aspect is that since each plugin has a name, we can insert a configuration block inside the restart.yaml file in the plugin arg section. In short, inside this block, we will find a list of different plugins. Each of them is identified by the name. In this case, for example, we have a plugin called Ping. We also have some configuration-specific options which are enabled, secured, and URI. Then, we have the possibility to specify a series of arguments too, which can be used inside the plugin. So, first things first. In the Plugins Args section, we will find a block related to the plugins which is identified by the plugin name. Enabled column true allows to enable or disable the plugin. This will override the parameter we inserted inside the @register plugin annotation. Secured, which is false by default, allows us to choose to enable or disable the security on that plugin, or, to be more specific, on that service. This means that, if it is disabled, anyone will be able to access the service. On the other hand, if secured is enabled, it will be necessary to go through the authentication process. Then, we also have URI. This can override the default URI we set inside the annotation. Finally, those we see here are the possible arguments that we should pass to our plugin. For example, here we see an MSG argument, which is actually the ping string. Obviously, here we can add other arguments with other values according to our needs. What is inside the configuration can be used by the plugin through a method which is noted as @injectConfiguration. Therefore, in the following examples, we can see that there is a method called init, which is noted as @injectConfiguration. A map called args is passed to it. Then, through this argValue method, which is a helper, it is possible to extract from the args map all the different elements. In this case, this instruction allows to extract the MSG content and to save it in an appropriate variable. So, let's imagine that we have to pass a series of information in order to configure the plugin. Then, we can list them in this block and recover them again through this kind of method. It is possible to specify some additional dependency injections. That is, next to the @injectConfiguration, we have other two annotations. One of them is the @injectPlugin registry, which allows a plugin to refer other plugins. What does it mean? Well, Restart has a kind of registry, which here is called registry. Inside this registry, there is the list of all the plugins. Therefore, we can add this registry inside our plugin. In this way, we can refer to other plugins added inside this registry to make some specific operations. Moreover, we can have the chance to inject a Mongo client object through the @injectMongoClient. This object was initialized at the start of Restart, and it is connected to the MongoDB database. Here we can see an example of the code. In this case, we have a Mongo client object, which we are going to inject. This allows us to interact with the MongoDB database. Service and Interceptor are generic classes. However, there are also some request and response specialized implementations. They simplify the development very much. We see them here on this list. They allow to deal with JSON, which is the most common format for data exchange, BSON, which is a specific MongoDB variant so that it can manage requests and responses related to the database, byte array to manage data blocks such as strings, and BSON starting from CSV requests. The advantage of these implementations is in the possibility to manage the requests and the response content in an appropriate way. For example, the byte array request uses a byte array, while the BSON request uses a BSON value, which is MongoDB specific. According to the implementations used, it is possible to use additional methods, that is, some helpers, to better manage the parameters found inside the requests. For example, the Mongo request, which is used by the Mongo service, shows the getPageSize method too. This because it is a parameter inside a query in the service. When a request coming from a client reaches restart, restart determines the service that he will have to manage, and so it initiates the request and response objects which will be used for the proper management. Let's now see how the services are structured. Based on the type of content, the service class implements one of the specialized interfaces which are found inside the restart common dependency. Specifically, we talk about byte array service, JSON service, and BSON service. In the following example, we see a service called Mongo Status Service, which returns the status of the server on which MongoDB runs. Since this service must interact with the database, it uses a specialization of the service class, which is the BSON service. In this way, it can manage the BSON format, which is typical of MongoDB. Particularly, in the part related to the initialization, we can see how a Mongo client instance is injected through the @inject Mongo client. This instance is created and installed when restart starts, according to what we previously saw. Obviously, since it is a plugin, we find the @register plugin annotation with the name and the description. We also see that the plugin is activated by default and that it will respond to the /status URI. We can see that we must do the override only for the handle method. This method is executed every time a request comes to the URI service, which in this case is the /status. Inside handle, we find the entire service logic, that is the entire code managing the service itself. The method has two input parameters, that are a request and a response. These two are of a type which is compatible with the interface, which in this case is BSON service. Therefore, as we can see, we have a BSON request and a BSON response. Inside, we can see that there are different methods allowing the manipulation of the request and the response. Request is get allows us to verify if the request is of a get type. There are also some equivalent methods to verify if it is a post, put, or delete type of request. Then, the possibility to inject the Mongo client allows to work directly with the database. For example, to access a specific database. Then, we can see here the operations which can be done on the response. For example, we can set the content of the response, which in this case will be equal to the server status that we get through the Mongo client, and therefore directly from the MongoDB database. We can set the status code, which in this case will be OK. To be more precise, in the case of a GET request, it will be OK. Then, we can also set the type of the content, such as JSON. In all the other cases, instead, we will set BAD request as a response code. This means that an error code will be returned in the case we get requests different from a GET on the /status URI. The types we just saw are the most common ones and cover most situations. However, we can create a service which can manage different types of requests and responses. In this case, it is necessary to implement the service-based interface rather than one of its specializations. Let's quickly look at this example. We will not spend much time on this because this topic is a bit more complicated compared to the others. Therefore, it would require deeper insights. However, we can see that in general it shows how to implement a service which will be able to manage XML requests. As we can see, in this case the plugin that is implementing the service does not use one of the interfaces we saw before. Instead, it uses a service-based interface, specifying the type of request and response. In this case, the request and the response are XML request and XML response. Talking about the part related to the @register plugin annotation, everything stays the same. However, in this case, it is necessary to make the override of 4 methods: request initializer, response initializer, request, and response. The first two take care of the request and response initialization, while the last two manage the request and the response. Moreover, it is clearly necessary to implement the XML request class to execute the initialization, manage the content, and do all the operations which are completely transparent when we use the basic types, but that require more effort and coding when we want to make a personalization. However, what we want to highlight is that Restart allows complete extensibility. Therefore, we can also use non-conventional types by implementing all the aspects which are necessary to make everything work correctly. Let's now move to the interceptors, which allow to analyze and modify requests and responses in different phases of their life cycle. This is done thanks to the intercept point parameter inside the @register plugin annotation. In fact, if we go back to the table we previously saw, we can see that the interceptors have an intercept point parameter, which can take one of the following values: request before auth, request after auth, response, and response async. So, this is a non-compulsory parameter, because by default the request after auth is applied. Hence, for what concerns requests, the interceptor can intervene before or after the authentication phase, and then relate to a response or an asynchronous response. It is possible to avoid the interceptor's execution by setting inside a service a .intercept parameter. If this parameter is set on true, the interceptor won't be executed when the requests are coming to this service. Let's go back again to the interceptor. An interceptor can manage proxate requests, but this is one of the advanced features that we will discuss in one of the following videos. Moreover, it can also deal with the requests managed by the services. This last type of requests can be intercepted only when the request and response types match those declared by the service. On the other hand, proxate requests must have request and responses which extend buffer request and buffer response. In fact, those we see are the implementations offered by Restart Commons. As we can see, the interceptor type matches the service type. So, a byte array interceptor matches a byte array service. This means that an interceptor of the byte array interceptor type can intercept only the requests managed by the services implementing the byte array service. This is also true for the JSON, the Bison, and the Mongo. Here we can see an interceptor example. In this case, it works on the Mongo, therefore it implements the Mongo interceptor interface. There is always a handle method inside which there is the logic, that is the entire code, which in this case is handling the response. In fact, let's look at the setting for the @register plugin. We have the name and the description, which is telling us that this interceptor removes the secret property from the get/call calls. This means that when we make a get call on /call, which is a collection, it removes the secret and therefore it prevents the password from being viewed in the response. In this case too, we can see that handle has two arguments, a request and a response, which are of the same type of the interceptor. In fact, they are a Mongo request and a Mongo response. Because the request and the response are compatible with the interceptor and service type, a number of methods which can correctly manage the content are already available. In fact, this type of interceptor works on the response level, and the intercept point is intercept point.response. So, A request comes in, but Interceptor does not work suddenly. It starts working only when the response is returned. In fact, we can see that it is possible to access the response content, to work with Mongo documents, to remove secret, and to do several operations on the content. Notice that here we can also find another method, which is resolve. This one is somehow connected to handle because inside resolve we have a sort of Boolean condition which allows to call upon the handle method when resolve returns a true value. This means that we can insert conditions inside resolve. These conditions must be evaluated, and only when all of them have been verified and the result we get is a true value, then handle is launched and the logic contained inside it is executed. For example, in this case we can see that the resolve checks that the request is of a get type, that the content is different from null, and that the collection name is equal to call. Finally, let's take a look to the initializers which allow to execute some operations in the initialization phase, namely to define a personalized logic when restart starts or right after it. This can be useful in different contexts. For example, it can be used to verify the validity of a license before starting the software. In fact, an initializer is essentially an interface extending configurable plugin and which only has one method which must be implemented, the init method. So, as we can see in this example, we have a confirm startup initializer class implementing an initializer. Then, inside the init method, the code which will be executed in the initialization phase is inserted. This specific example simply blocks the start of restart until we press the Enter button. As we can see, inside the @register plugin annotation, next to the name of the description, we have other two parameters, which are priority and init point. Let's go and take a quick look at them inside the table. Here we are. So, they are two parameters which are specific of the initializers. The init point can take two different values, before startup and after startup. It is not compulsory because by default it is applied after the startup. This means that after startup is the default value. In short, it is saying when the initializer must be executed. This means that the code inserted in the init method must be executed either before startup or after startup. On the other hand, priority is a numeric value that indicates the execution priority. This is a non-compulsory parameter too, and its value is 10. Here are lower values, meaning a higher priority. Let's go back to the example. We find here that the priority's value is 100, and init point's value is initPoint.beforeStartup. After all this theory, let's move on to the practice and let's work on some coding. First, let's move on GitHub, where we find the restart example repository. Here we can see several examples of plugins, from which some of the code snippet we saw in the official documents are drawn. Particularly, Bytes Array Service is the classic Hello World. Mongo Status Service shows an example of MongoDB interaction by taking advantage of the client injection. Random String Service introduces the use of the additional dependencies. User sign up instead is the most complete example, but also the most complicated example compared to the others. Of course, we will not be able to analyze all of the examples because of time reasons. However, the README documents inside each project are very explanatory. In any case, it is always possible to ask for support in the case of doubts. Let's see how to move on. As we already saw for restart, to continue with the compiling of the code, we only need at least the 11th version of JDK and Maven. Therefore, we must clone the repository, move in the restart examples directory, which will be consequently created, and download restart as we saw in the previous video. We can choose between the zip archive or the tar.gz. Then, after unpacking restart, we can move back inside restart examples, and in each of the directories corresponding to the different plugin examples, there will be a README file with more specific instructions. To simplify as much as possible the first approach with the code, we work with Hello World. So, as we saw, it corresponds to the Bytes Array Service plugin. Let's skip for now the part describing the service and let's focus on the part related to the compilation and the execution. All of this is inside the README file. Apart from the indication we already saw, we have two different alternatives concerning the compilation and execution. One of them is based on Docker and it allows to automate all the operations. However, it requires that we have Docker in our machine. As an alternative, we can make the same operations manually. Let's see this second way first. We simply have to compile the plugin by using the mvn package command. This generated the jar file inside the target directory. This file must be pasted inside restart's plugins directory. Then we must start MongoDB in our machine, move inside restart again, and start the process with the same command we saw in another video, which is java-jar restart.jar etc/restart.yaml -e etc/default properties. This means that in this case, we have to execute restart by using the configuration we find inside the default.properties file. As we saw in the previous video, if everything is OK, we will see the restart started string in the log files. Of course, this method requires to execute several operations manually. As an alternative, it is possible to automate the process by executing the run.sh command. This is a shell script that we are going to see directly on GitHub and which makes a number of operations in an automatic way. This means that it compiles the code through Maven and it generates the jar file. Then, it pastes this file inside restart/plugins. We take for granted the fact that the restart and the restart examples directories are at the same level. Then, it starts a MongoDB instance, or better, a temporary MongoDB Docker container, and it starts restart on the 8080 port. This way, the entire infrastructure is being executed. Of course, at the end of the test, it is enough to execute Ctrl+C to interrupt the script, to stop restart, and to delete the MongoDB container. This annotation concerns the execution on Debian Ubuntu. In this context, if the user on the machine is not inside the Docker group, or this group is not there, it is necessary to execute the run.sh script with sudo. Therefore, with the root privileges, which are necessary to manage the socket Unix. Now let's go back and see the run.sh. As we can see, it executes another script found inside the restart examples root. Then it executes the Bytes Array Service.jar. Let's go back a little bit. This is utils.sh, another shell file. We can see that, inside the run function, it sets the MongoDB version necessary to create the temporary instance on a specific network with a random ID. Then, we see the operations which are being executed. There are the mvn clean package, the jar copy inside the restart/plugins, a series of informative strings with echo, the creation of the network on Docker, which we previously specified, and then the execution of the container. This container is called Mongo1 and uses the image we set, which in this case is Mongo 4.2. Of course, since this container has the -rm option, it will be removed when we stop the execution. Then it starts MongoDB execution. It moves in restart and it executes the command. When we stop the container with Ctrl+C, the cleanup function is recalled, which does all the cleaning operations. This means that it removes the plugin, it stops and removes the container, and it also removes the network we created. So, the second way is surely simpler because it is all about executing a script, but it requires a Docker to be installed on your machine. Now we can take a look at the plugin. Let's go inside the source code to see in the practice what we were talking about in the first part of the video. As we can see, the plugin is made of a class, Hello Byte Array Service, which in this case implements the Byte Array Service interface. This happens because we manage some simple strings. The plugin is noted as @register_plugin and is given hello as a name. There is the description, it is enabled by default, and the default URI is /hello. So, the service will answer calls on /hello. Then, as we can see, there is the handle method. This is the only method requiring the override. This method has the request and the response in entrance. The request and the response are obviously of a type which is compatible with the interface implemented by the plugin. Therefore, in this case, we have byte array request and byte array response. And here we can see what is being done. Inside handle, there is the service logic and there is the possibility to inspect the request content. For example, this instruction tells us that if the request is a GET, a message is printed. Then, through the GET query parameters, we can verify if there is a name parameter different from null. At this point, the response message will be obtained by linking hello with the name that has been passed among the parameters. Then, as we can see, we can manipulate the response and therefore we can set an HTTP code, which in this case will be the classic 200. Otherwise, if the request is a post, the content of the request will be passed through the body and therefore, with the request.getContent, we can get the request content. We check if this body is empty, and if it is not, we link the hello string with what is found inside the body by setting the correct status code. In all the other cases, that is, if we have a request which is not a GET and is not a POST, we can set the status code as bad request. Moreover, we can also see in the last part the response content type and the content which corresponds to the response message converted in byte, so that it respects the response types. In this case, it is the type related to the byte array. Good. Now, let's do a test directly on the terminal. After moving inside Restart Examples, let's go inside the bytes array service directory. And let's execute run.sh. I am on an Ubuntu machine and therefore I execute the command with root privileges. We wait a few seconds while the compilation procedure takes place. Once it is finished, the container creation operation starts. Let's now look at the logs, so that we can have an idea of all the operations which have been executed. Let's start from the beginning again. We executed our sudo./run.sh command. The compilation through Maven started. The build was made. Then, the bytes array service.jar file was created inside the build success target directory. The next phase is the creation of a Docker container related to MongoDB. This is the ID which is generated in a random way. Once MongoDB startup was done, Restart started. So, these are all the logs related to the start of Restart. Let's go and find the part we are looking for. We see here that there is the connection to MongoDB and Restart that started on the 8080 port. I also wanted to quick see the part related to the plugins. Inside the restart/plugins directory, there are the bytes array service and the two plugins that we already know, which are the Restart Security and the Restart MongoDB. So, these plugins were enabled. In fact, we see here all the active URIs /bound, /hello, /ping, and /tokens. So, everything that is accessible. In particular, the /hello is the one related to the plugin example we are working on, which is the Hello World. Here we can also see that the security level is shown. All these URIs or services do not need security, not even in the case of /hello. On the other hand, the one related to the Mongo service requires security. Security is also active on this service called CSV Loader, which allows to upload CSV files. At this point, we can try and see if the service works correctly. So, we can make a curl on http localhost colon 8080/hello. Then we pass the parameter. In this case, we are making a get with the name equals Mauro. Let's also add some operations to see the headers which are being exchanged. In fact, as we can see, the response is Hello Mauro. Going back to the logs, we can see notes in relation to the request we just made. We can see that the hello byte array service was called, that the parameter passed is name equals Mauro, this is the response, and this is the call. Here is the get targeting this server. This is the IP, that is the port number of the client who made the request, and this is the status. To stop everything, it is enough to do Ctrl+C. As we can see, the container is removed, as well as the network on the Docker which was created for this operation. Finally, let's see a template for the plugins development, which is made available on GitHub. This is the Restart plugin skeleton repository. In short, this is a basic model to use as a starting point to build our plugins. It offers some useful tools to make the development process easier. The service is extremely simple. Let's take a quick look at the source code. It is a service responding on the URI/SRV. When a GET call is made, it responds with a Hello World string. What we want to analyze most is the set of tools that are available to simplify the development phase. In particular, we can see that there is a Docker Compose YAML file which allows to start a MongoDB instance which is necessary to make Restart work. So we can manage the creation of the necessary containers in a completely automatic way. Obviously, it is necessary to have Docker inside our machine. On the other hand, in the bin directory, we can find several scripts shells which allow to do different operations. Restart is the main one, as we're going to see now in more detail. It allows us to start Restart's instance, to do the deploy, and to copy it inside the instance itself. This instance is started in a development way, that is, by using a particular Java virtual machine called DCEVM and by enabling the debug on the 4000 port. Let's see what we're talking about. Here is a Java virtual machine. Here we can see the official website page. It enables the extended hot code replace, that is the possibility to start restart automatically with every alteration of the source code. Let's now see how to compile and execute our plugin by using the scripts we just talked about. We moved back to the terminal. We are inside the Restart plugin skeleton directory, and the first operation we have to do is the compilation of the plugin. Therefore, we execute mvm clean package. This way, we are going to compile and generate our plugin's jar file. Let's clean the screen and let's execute the script found inside the bin restart.sh directory. We can execute two different profiles. One of them is the restart, which also activated the MongoDB service. For this reason, in this case, it will be necessary to have a MongoDB instance running on the 27017 port. The other one is the microd, which does not activate the MongoDB service and therefore can be used to create microservices. In both cases, the Java Virtual Machine DCEVM will be downloaded at the first start. Now we go and execute the restart profile. Be careful about this difference. Here we have restart and here restart, which is the name of the framework. So, as we can see, the first operation made is exactly the restart download one. Then, the Java Virtual Machine is downloaded. The time necessary for the download depends on the speed of the connection, because we have to download around 185 megabytes. This operation is carried out the first time we execute the command. Let's give it some time. OK, the Java Virtual Machine was downloaded and the plugin deploy was carried out. This means that the jar made in the previous phase was pasted inside the plugin's directory of Restart's installation, and Restart was started. So, as we see, we can check the logs, which are created inside the restart.log file inside the Restart plugin skeleton directory. So, if we execute the command, we can see what happened. Restart has been started and it is now running. We also see the active URIs, including the SRV, which is the one we are interested in because it is related to our plugin. In my case, a MongoDB instance is running and therefore no errors were shown. Now, let's try to stop Restart's instance. To do so, we can use the /bin/stop.sh command. The script stops Restart. Let's now see what happens when we have Restart's profile without MongoDB running. I already started sudo docker compose down. So now we are in a situation where there is no MongoDB instance running. Therefore, if we execute the previous command again with the restart profile, and since it is necessary to have MongoDB, we get an error. So we are told that MongoDB is running on the 27017 port and that we can start it with docker compose app-d. We see instead that we can start the microd profile without getting any error simply because with this second profile it is not necessary to have the MongoDB service. Therefore, as I was saying, this can be used in the development of microservices. There are no errors. Therefore, let's make a curl http localhost 8080/srv call. And here we got a response. Now, let's stop Restart again. Let's follow the advice we got and let's execute docker compose app, and we add d to send it in background. On Ubuntu, I have to execute sudo with root privileges. And as we see, a network is created and the Docker container is activated. So, by rerunning start.sh with the restart profile, we can see that we have no problems. So, we can redo a call, and here we get the response in a very simple way. We are now back on the scripts list inside the bin directory, and we saw restart and stop. The Notify OS X allows to have notifications on OS X when restart is restarted. The watch file instead, or better, the watch script, extends what we already saw, since it allows the rebuild of the entire project and the automatic restart of restart with each modification of the source code's configuration files. As we said, this is similar to what happens in the Node.js world. As it is shown in the documentation, next to the requirements we already saw, such as at least Java 11, Maven, and the Docker, to use this specific functionality, we also need to use the Enter tool. This tool can be installed directly on Mac with this command. In the case of Linux, instead, it is necessary to compile the source code. We find the instructions directly on the GitHub repository of the project. On the other hand, this tool is not available on Windows, and therefore we will have to use Linux subsystem. This will then require some more effort for the configuration of our development environment. Finally, let's say another thing about dependencies. As we already said, it is possible to use dependencies inside the plugins, apart from Restart Commons, which is the fundamental one because it makes available all the different restart interfaces to be used to make plugins. However, we also said that these jar files do not have to be duplicated. They can be already included inside the core. Of course, in the compiling process, all the dependencies jars will be inserted inside the target/lib directory. If one or more dependencies are already available inside the core, it is necessary to ensure that they are not being duplicated. This is done by adding inside the Maven configuration file the scope provided block. As we can see, it is automatically inserted for Restart Commons because the same dependency is already integrated inside restart.jar. Of course, we can look at the libraries which are already included by executing the command mvn dependency :3-dscope equals compile. Finally, we can also modify the name of the jar file by acting on this code block inside pom.xml file. That's all for now. See you soon with new tutorials!